Hey guys, Buildzoid here, and today we're going to be taking a look at one of my favorite AM4 motherboards, the Gigabyte B550 Vision D-P. Now, funnily enough, this motherboard is not from Gigabyte. So basically, I had a fan of the channel just like send me an email asking if I want a B550 Vision D-P, and I figured, they must have like a spare board or something, so I just sent them the P.O. box address. And they shipped me a brand new, well, they bought a brand new B550 Vision D-P for me. So, yeah, huge thank you to them for doing that because it's not really like it's not a super expensive board, but it's also not exactly cheap. So that was really surprising. Like I really thought they had like a spare board that they weren't using, but nope, brand new Vision D-P. So huge thank you to them for doing that because like I did try to get the original Vision D from Gigabyte, but at the time that I asked, they apparently just didn't have any boards to send out. And I think they were like out of production because they were I think they were transitioning to the production of the D-P or something. Either way, and then I sort of forgot about it. And then that email showed up, and I just kind of went along with it. And I honestly, like, I feel kind of bad about it because it's like I could have just asked Gigabyte, they would have probably dug up a board eventually if I kept nagging them about it. But yeah. Anyway, now we get to take a look at, in my opinion, well, like, yeah, one of my favorite AM4 motherboards because the biggest problem I have with the B550 Unify X is that it doesn't do multi-GPU. This fixes that. This has the PCIe switches not wired to a bunch of M.2 slots, which is what the Unify X does. No, this has X16 support on this slot, which also goes down to X8, and then over here we have X8. Unfortunately, the board does not have an SLI license, so I can't exactly whack all of the GTX like 700, 600, 500, 400 series cards that I have into this, but it does do multi-G, like it'll do quad crossfire, triple crossfire, dual, like it'll do any crossfire setup that you could do on any other X570 or B550 board. So, or actually most B550 boards won't do even two-way crossfire. So the multi-GPU support is a lot better than most motherboards. Especially on the B550 chipset, because the PCIe switches are actually pretty damn expensive thanks to PCIe 4.0. So, yeah, which is kind of annoying for me because most of the SLI compatible GPUs are PCIe 3.0 anyway. So, it's just like it could have been PCIe 3.0 for all I care. It wouldn't have made a difference to me. But anyway, yeah. So the board has multi GPU support. Other than that, we've got a really strong rear I/O. Well. No, not my favorite flavor. I'm a big fan of just having tons of Type A USB ports, which this doesn't really do because instead this has all these fancy new connectors like dual Thunderbolt with a DisplayPort input over there, HDMI output for if you have an APU. Then you've got dual 2.5 gig LAN. I'm pretty sure that's Intel. And then Wi-Fi 6 from Intel. So basically, I'm never going to use this, never going to use any of that, never going to use one of those 2.5 gig ports is never going to see any usage from me. I might actually use the PS2 port, occasionally you need a driverless way of connecting a keyboard, which let's say you're installing like Windows 7 or something. Never going to use that either. This may be, because like the board is just generally really, really good at overclocking. So yeah, if I was doing some APU overclocking, I don't see a reason why I wouldn't stick the APU in this instead of something else. But yeah, so the rear I/O is sort of like it's the Vision lineup for Gigabyte is supposed to be their workstation lineup. So I get that they have all these fancy ports that I'm never going to use, but at least it does still have 7 Type A USB ports, which it's kind of like, yep, that's basically enough for like, if I ever move the board into my daily system, that is basically enough ports for my daily system. Because, yeah, currently the board's primary purpose is just being my go-to GPU test bench because, like, it just does everything I wanted a B550 board to do, because previously it was like, oh, I want to run SLI, I need to go dig up the, like, X570 Godlike, and the Godlike just kind of sucks at so many things so badly. Like, the only thing that I really keep that board around for is its weird PCIe slot layout. Then there's and I never actually got SLI working on it, so That's fun. You know, and then it's like, and then for, well, the Unify X is only really good for memory overclocking. It's not really usable for anything else. So, you know, whereas this is a sort of like do everything motherboard. And that's why I'm a huge fan of it, is just like, it just has so many options. And I guess that even applies to the rear I/O, except this is the part where I don't care about the options. So anyway, let's move on to the rest of the functionality on the board. You get an M.2 slot connected directly to the CPU that runs at PCIe 4.0. This one's connected to the chipset, and I believe that one only runs at PCIe 3.0. I couldn't tell you the difference between those in terms of performance because I've never used an M.2 drive in anything. I'm not even sure that my laptop has an M.2 drive in it. I've not checked. Probably does. I don't know. I don't care. Anyway, the one thing that I'm kind of annoyed about is there is only 4 SATA ports. That's, yeah. But I guess, like, so this is the motherboard where I'd actually be willing to start using M.2 drives just so that I can keep using this board. Like, that's actually the case, because my personal system right now is on, like, 3 SATA drives. So I guess if I ever upgrade, like, if I ever put this board in my daily system, I would have to start using M.2 devices, and honestly, for a board for this board, I'd be willing to make that sacrifice. For any other motherboard, nah. I'm using SATA, thank you very much. And it's not really a sacrifice, it's just kind of like, yeah. I've just not seen a reason to use M.2 drives until a motherboard literally forces you to by not having enough SATA ports, so, yeah. But if I, like, with this board, I'd be like, yep, that's, like, honestly, for everything else, worth it. So we've gone over the PCIe slots. This one's attached to the chipset. You get a Wi-Fi card over there. I guess you could ditch that and replace it with an M.2 drive if you wanted to. One of those, like, super tiny ones. And what else do we have? Right. My favorite feature, we have a postcode. Actually, no, that's not really my favorite feature. The thing is, this board has a nice mix of just, like, things I like. We've got multi-GPU support. We've got a postcode. We've got a crazy, like, Gigabyte's crazy strong 6-layer daisy chain topology. The VRM can power literally any CPU you can stick into the socket. Like, you know, it's not the best VRM on the X570 platform, or on the AM4 platform, more like. But also, and then another thing is, like, it doesn't have an X570 chipset. It has B550, which is so much better at BCLK overclocking. But yeah, so you get a postcode, which is super helpful if you're doing a lot of memory overclocking, which this board's actually really good at, which is why that postcode is so useful. Above that, we get a Q Flash Plus button, which primary purpose of that is to update the BIOS of the motherboard without having a compatible CPU, though technically that should also be able to recover from corrupted BIOS flashes, though it's not really, like, meant for that. It can probably pull that off. Anyway, speaking of BIOSes, there's only one, and this is sort of the, like, so this is the funny thing, is, like, if I compare this to the B550 Unify X, which is another one of my favorite AM4 motherboards, the Unify X also only has one BIOS chip, so that's one of the things where it's like, yeah, well, like, I don't really have better options. You know, it's like I can have this motherboard with 4 DIMM slots and multi-GPU support and 1 BIOS, or I can have this other motherboard with no multi-GPU support, 2 DIMM slots, and 1 BIOS. And actually, I do like the 2 DIMM slots, but the thing is, with Ryzen, if you're staying within synchronized Infinity Fabric speeds, how many DIMM slots you have basically doesn't matter. So the lower DIMM slot count is only really useful if you're pushing crazy high frequencies on, like, single rank memory configurations. And when you're doing that, the Gigabyte 6-layer daisy chain is only like a couple hundred, it's not even a couple hundred megahertz slower than the 2 DIMM, 1 DIMM per channel topology of the B550 Unify X. So it's not a huge like, it is a difference, but it's not huge. And so, you know, like, this board is not the best at any one thing, but it is a very good combination of just functionality that I really like. And so, yeah, single BIOS compared to the B550 Unify X. And then, you know, there's the B550 Aorus Master, which has 2 BIOS chips, but doesn't have the necessary switches to manually choose which BIOS chip is active. So the dual BIOS on a B550 Aorus Master is actually a downgrade. It makes the board worse because it is so annoying to overclock on, because the board will randomly switch to the backup BIOS if you fail too many, like, if your overclock settings fail to boot too many times in a row. and then you need to like power cycle the power supply so that you get back to the main BIOS chip, and like it is a nightmare because you might be like trying to get some memory settings to boot, and then it boots up and you get into the BIOS and you find out it didn't actually train the memory settings you were trying to boot. It just went to the backup BIOS chip because there's not even an LED on the motherboard to indicate which BIOS chip is active. So the fact that this is single BIOS is actually an upgrade over the B550 Aorus Master. So yeah, it's kind of like, is this the perfect AM4 motherboard? No, but it gets really damn close. Really, really damn close. So yeah, and since we're already on the topic of overclocking, this does have a B550 chipset, and I'm a huge fan of the B550 chipset when it comes to overclocking because unlike the X570 chipset, the B550 chipset doesn't freak out every time you raise the BCLK by more than like 2 megahertz. I've already had this motherboard all the way up to like 107 BCLK, and it doesn't complain. You literally just go into the BIOS, make sure that, you know, none of your frequencies go out of whack. You don't even need to adjust the PCIe speed or anything, right? Like, it's like a thing that I think the board does it for you when you raise the BCLK that much, but either way, like a lot of the time, if you're raising the PCLK really, really high, you might have to lower the PCIe generation because PCIe 4.0 with 7% higher clock speeds doesn't really work very well. But you don't even have to do that on this board. Like literally, you know, I was messing around with like max memory validations on this board with some Samsung B-Die, and I was running like 4933 by 107 BCLK. To boot, you know, over 5,000 megabits per second on the memory. And it's fine. Like, B550 just does that. If you tried to do that on an X570 motherboard, the chipset won't initialize because the chipset's freaking stupid. So B550 is great. And actually on B550, the hard limit for BCLK is 118 megahertz. And that's because, like, technically in the BIOS, you can punch in 120. But in my experience, the clock gen on all of the B550 boards doesn't actually seem to be able to go to 120. So basically, if you punch in 118, you get 118. If you punch in 119, you still get 118. And if you punch in 120, you still get 118. So, like, this is why in the theoretically perfect motherboard video, I was like, I want a dedicated clock gen because the built-in one sucks. Yeah, still way better than the clock gens you get on X570 because on X5, which actually not true because technically X570 boards, a lot of them have really nice clock gens that'll do like 0.01 megahertz increments, so super granular BCLK control. There's just one issue. You can't boot if you raise the BCLK like more than 2 megahertz. So like what's the point of having a really fancy clock gen on a chipset that literally can't do proper BCLK overclocking? So yeah, anyway. And so ultimately, I'd rather have the really limited, you know, clock gen with a B550 chipset than a great clock gen on an X570 chipset because the X570 chipset basically invalidates the existence of said clock gen, you know. So, yeah, anyway. And that sort of covers, like, why this is my sort of favorite mix of features. It's just, it kind of does everything pretty well. Like, the B550 Unify X is slightly better at memory overclocking. It also has a slightly more granular clock gen on it, though it doesn't fix the whole, like, you can't go over 120 megahertz thing. However, the thing is, you also, like, there's not really much reason to push that insanely high BCLK. The main use of BCLK overclocking is, like, if you want to run, say, 4040 on the memory instead of 4066, right? Like, if you want to get these weird, like, not actually an available memory ratio type overclocks, that's where the BCLK overclocking gets super handy. Or if you want to raise the infinity fabric by a very small amount, you can use BCLK with like some awkward, you know, FCLK ratio to get like, you know, because normally the FCLK frequencies go like 20, 2033, or well, you get 1900, 1933, 1966, 2000, 2033, 2066, 2100, you know, and you get these really big steps in the FCLK frequency. Well, what you can do on a B550 Vision is you can go to the 2000 infinity fabric ratio and then run 101 BCLK, and you know that is admittedly a 1% overclock, but it's 2020 instead of 2033 for your infinity fabric. So if 2033 is a little bit too unstable for whatever benchmark you're running, you can run 2020. And like that's why B550 is the superior platform to X570 if you're serious about benchmark. Like if you're, really fit like dialing in your memory settings, because you actually have the flexibility of being able to do stuff with the BCLK. Whereas on X570, the main issue run into with X570 is like, well, it's probably not even going to boot. Which also means you can boot much higher memory speeds on B550 than on X570, because as far as I can tell, the AMD memory controller seems to tie memory training to the actual memory ratio. So for example, on the B550 Vision, I can get the highest frequencies out of this board using the 4933 ratio. Like I can do higher memory speeds on 4933 than I can do on like 5000 or 5100 or 5200. Like I can actually exceed 5200 megabits per second on the 4933 ratio, whereas if I tried to use the 52x ratio, it doesn't even post, right? And on X570, you can't do that because if you raise the BCLK that much, it won't post because of the BCLK. It won't be like your memory will train, but the chipset won't initialize. So yeah, B550 is the best overclocking chipset, and anybody who says otherwise is wrong because they've never played with the BCLK properly. So anyway, let's talk about the power delivery, because obviously it's all great that we have all this flexibility in the memory overclocking section. How about powering the CPU? Well, luckily, the AM4 CPUs don't really pull that much power, and also AM4 motherboards have an awful lot of space for power delivery on them. So what we're looking at here is a 6+2 phase, where this part is the SoC, which of course is a 2-phase, and then the rest of it is vCore, which is a 6-phase, and like that's fine, right? We don't need super high phase counts if the rest of the VRM is designed appropriately. And we've got 12 power stages in the vCore VRM and 2 power stages in the SoC VRM. The controller is this chip right over here, and that is a Renesas RAA 2290004, not the highest end voltage controller that you can find on an AM4 motherboard, but the thing is the differences in voltage regulation between AM4 motherboards are very, very, very small, so it doesn't really matter. So that's fun. Then and that just runs 6+2, and this is why it's actually running 6+2, because the RAA doesn't do more than 8 phases total, so that's why we're looking at a 6+2 phase configuration. Because also Gigabyte didn't chose not to use any doublers. I think at the time the justification for this was that Intersil ran out of doublers. Yeah, actually, I'm pretty sure that's the case. Intersil ran out of doublers, and so Gigabyte re-released a bunch of their B550 motherboards, which previously used doublers, to not have doublers. Doesn't really make a difference, because the thing, Gigabyte, when using those ISL 6617s, they didn't even run them in doubling mode. They ran them in synchronous mode, so you still had a 6-phase with just slightly better per power stage current balancing than what you'd normally get. But the thing is just if you have a 12 power stage vCore like this using 60 amp power stages, there's not really much of a difference. There's not a huge difference thermally between having those 6617s and not having those 6617s. And without the 6617s, you get slightly better transient response because there's less delay on the PWM signals. So the actual power stages used here are NCP 252160s. These are 60 amp DRMOS components, so they're a bit dumb. Actually, they're really dumb. They have thermal protection, and that's about it. No built-in current sensing, no fanciness like that. But they are 60 amps, and they are reasonably powerful. So this is not that far off in terms of VRM efficiency compared to the B550 Aorus Master. So a 500 kilohertz switching frequency, though it is worth noting that the Master has its power stages spec'd at 1.2 volts, whereas this is only spec'd at 1 volt, but well, which it does make a difference. It's not it's not a huge difference. Anyway, and also the Master is 14 power stages and 14 phases, whereas this is just 12 power stages on 6 phases. But yeah, but it's not really well, we'll get to the efficiency calculations right now. So 100 amps output current. The VRM heatsink design will make more of a difference, and admittedly the B550 Aorus Master's heatsink is a better heatsink than what this comes with, but Either of these is completely, like, more than capable of powering a 5950X, so I'm not too worried about that. So 100 amps, it'll produce about 10 watts of heat. 150 amps, it'll produce about, and this is just the power stages, not accounting for like power plane losses and inductor losses. 150 amps, it'll produce about 13 watts of heat. 200 amps, it'll produce about 16 watts of heat, so really good efficiency. For comparison, though, the Master would actually do 200 amps with about 14 watts of heat, and the same is true for the B550 Unify X, which uses basically the same VRM that the B550 Aeros Master has. 300 amps output, this is where we start getting like the really big differences, but the thing is, under normal, like, under most circumstances, well, the 5950X running LinPack with tuned memory settings is capable of hitting up to 250 amps. But for sustained loads, you're not really going to be hitting that level of current, and LinPack power cycles quite hard. So basically, when you run LinPack, there's the main sort of actual doing calculations part of it, and then there's the memory shuffling part of it. And so during the calculations, it pulls insane amounts of current, gets super hot, and actually the CPU is super difficult to cool at that point as well. And then on the rest of LinPack, it actually doesn't pull that much current. So LinPack doesn't necessarily end up with doesn't really run a lot hotter on the VRM than, say, Prime 95, because LinPack, on average, the average power draw of LinPack isn't actually that insanely high. It's just the peaks that are super ridiculously high. But anyway, at 300 amps output current, the VRM would produce about 29 watts of heat, whereas the Master at this heat, like, current output level would produce about 24 watts. And that's also at higher voltage, so yeah, the Master is more efficient, but not by a huge margin. And also at, like, the difference only becomes somewhat significant once you get into these really high current draws. Like, this is LN2 overclocking territory. And the same goes for 400 amps output current, where this VRM would produce about 45 watts of heat, which is actually, like, that's quite hot. But also, like, you're not hitting this on ambient. Like, there's no way. You'd have to be on LN2 to hit that kind of current draw, and I'm not even sure that on LN2 you would hit that kind of current draw. Because the thing is, when you go sub-zero, like when you run CPUs on LN2, it massively reduces their leakage, so their current draw for a given voltage goes down. And Ryzen doesn't scale to super insanely high voltages. Like, yeah, it really doesn't scale to super insanely high voltages. So anyway, 400 amps. Like, I fully intend to actually use this motherboard for benching the 5950X on LN2. That is very much what I plan to do with this board, because it's just so good at everything. So why would I use anything else? So 45 watts heat output. For comparison, the Master would be producing about 35. And so now we have a really big gap, right? Like, that's 10 watts heat output difference. And that makes sense, because the thing is, the Master's VRM is actually arguably too big for the AM4 platform at ambient, because it's 1470 amp smart power stages. And so it's super overkill. Like, it really doesn't hit the peak of its efficiency curve until 200 amps. And then because it's a 70 amp smart power stage rather than like a 60 amp part, the curve falls away much slower past the peak of the efficiency curve. So yeah, also there's just more power stages. So at the really high currents, which you're not really going to hit on this platform, the Master has a big advantage, but like, you're not going to hit that anyway. So this is completely fine. Yeah, so I really like this VRM. Like, originally I thought this, like, before I took the heatsink off, I was pretty sure this was going to be on 50 amp DRMOS components, because that's what Gigabyte has on most of the rest of their B550 lineup. So I was actually surprised to see these 60 amp parts, and they are pretty good. So yeah, like, it's like, I was expecting it to be a lot further behind the Master than it actually is. Right, like, this is only significantly behind the Master in terms of performance once you hit like 400 amps, and it's just like, well, you're not going to hit that, so doesn't matter. Or if you are going to hit that, it's going to be for such short loads on LN2 that it's still not going to matter. So yeah, I do like this VRM. The one concern with LN2 overclocking on this board is kind of the single 8-pin power connector. It is on, solid, like, these are solid metal pins, so that's the high current variant of the 8-pin power connector. And at ambient, this is more than enough. Like, this connector can handle plenty of power for even a maxed out 5950X on water cooling, as just on LN2 that you might be cutting it pretty close to the specification for that 8-pin. So yeah, maybe I might add an extra power connector, because I'm not against modifying the board, just because like I like everything else about it. So yeah, oops. So back to the front layer. So that's the V-Core VRM, and more like it'll do everything you need. Also, it's a 6-layer PCB, so the heat dissipate, like, because you can get similarly sized VRMs on some 4-layer boards on AM4, and those run pretty hot. This will run a bit cooler because just the PCB is a bit better heat sink, and there's more layers for the current to be transferred to the CPU socket through. Now, I guess speaking of the layer count, what I do find kind of interesting about this VRM design is that they don't have a ground fill behind the power stages. Because a lot of high-end boards will actually do that, where you just put a big old ground fill right behind all of the power stages. And we don't see that here. And I think that might be partially because originally there would have been a bunch of doublers and the necessary supporting components for those in this area. And since they ditched the doublers, I guess they just didn't replace them with a ground fill. And we do see some like you can see I think that's the PWM line running around there to the power stages. So yeah. So instead of having like a nice big ground fill behind the VRM, we just get these little ground pads for each of the filtering capacitors. So you have your input filtering and then some of your output filtering. And since we're already on the topic of capacitors at this point, let's take a look at the socket. Yep, pretty standard Gigabyte. They did whack a SP, well, that's not an SP cap, that's a molded aluminum polymer from APAC. They're not as good as SP caps, but still better than having a through-hole capacitor. And speaking of, molded polymers, the entire SoC VRM is handled with those. We also have 2 of them on V-Core, but I'm pretty sure those aren't a case of like Gigabyte optimizing the VRM for better transient response. I'm pretty sure those are a case of they ran out of space, because if you look over here, you can see we have a bunch of like signal lines because there's some I/O that comes from the actual SoC itself. So you can see there's a bunch of like traces over here that we can't have more bulk capacitors over there. So since they run out of ran out of space for through-hole bulk capacitors, they slapped a few SMD ones by those phases over there on the back of the board. But the SoC VRM is entirely handled by molded polymer capacitors. So that's kind of neat, because these will generally have much better, well, actually not generally, they just have much better ESL than your through-hole capacitors, even if they're made by a cheaper manufacturer like APAC instead of, say, Panasonic, or I guess Chemet. Well, no, Chemet mostly does tantalum, so I wouldn't really count them. And the tantalums that I've tested have never really matched the performance of molded aluminum polymers. Even though they should share all the same advantages, I guess it's because you can get SP caps and like absolutely ridiculously low ESRs. But yeah, anyway, so this is also, like, it is worth noting that Gigabyte technically has the same output filtering on the SoC VRM of basically every single one of their AM4 motherboards, or at least the higher end ones. The cheaper ones, they'll go to the through-hole capacitors, because these are still really expensive. Like, yeah, they're not, Panasonics, but they are still way more expensive than through-hole capacitors from the same manufacturer. So this is actually sort of the higher end SoC VRM filtering that Gigabyte offers. And then for the bulk capacitance for the V-Core, we're looking at a bunch of APAC through-hole polymers, which are 560 microfarads, 5,000 hours rated at 105 degrees Celsius. Input filtering is handled by a bunch of FP caps from Nichicon, which is kind of interesting because you normally don't see a mix of different like brands on a board, but with the recent sort of component shortages, I guess APAC ran out of 16-volt capacitors, and so we have FP5, because normally when Gigabyte uses Nichicon, they have those black capacitors that you see on most Gigabyte motherboards. Those are from Nichicon, and those are rated for 10,000 hours. I don't remember seeing 5,000 hour rated FP caps on Gigabyte boards very frequently. Normally you would have 5,000 hour rated capacitors from APAC for the input filtering, but here we have Nichicons. I really don't think that makes a difference. It's just kind of interesting that they're mixing capacitor brands, because in the past, before we started here, before the whole electronics component shortage started, you'd basically, if you had a board, it was basically all APAC or all Nichicon or all one manufacturer. And now, actually over there, we see some Nippon Chemicons, right? There's another Nippon Chemicon over there, which is another Japanese capacitor manufacturer. who normally, like MSI likes using them a lot. Actually, I think this might be the first board I've seen those used by Gigabyte in a very long time. So, yeah, that's kind of interesting. Yeah, so the capacitor selection, it's not as nice as what you get on the Master, but I also don't think it would make much of a difference in terms of the voltage regulation performance. And also, since I mentioned this in the previous B550 motherboard PCB breakdown I did, this has somewhat more sensible thermocouple plate, or they're not thermocouples, but temperature sensor placements. So the SoC VRM temperature sensor is over here, which is not really ideal. You'd probably want it like there. But this is a lot better than, well, like this is fine. The SoC VRM doesn't have to handle a huge amount of power, so this isn't going to be super inaccurate. And for the V-Core, they put the temperature sensor over here, which I'm not a big fan of. I would have preferred it over there, but this is still a lot better than what they did on the B550M Aorus Pro, or whatever, like whatever the last, was it the M Pro? I can't remember, but the last B550 motherboard that I covered from Gigabyte, where they stuffed that temperature sensor like right here between the SoC VRM and between like two phases of E-core. And so that temperature sensor reads way off. It's way too, like way lower temperature than it should be. So this will be a lot more accurate. Also, this board has a more substantial heat sink with a heat pipe running through it, so that'll even out the temperature across the VRM quite a bit as well. So yeah, like all around this is just a nice, like solid VRM. It's not, you know, perfect, but it'll do everything I need it to do. Well, actually, I am sort of heavily considering messing with replacing all of the bulk capacitors with SP caps. Just like, you know, just to see. I'm also considering replacing all of the SoC capacitors with SP caps, which I don't expect to really achieve anything, but hey, we're like worth testing it out, because like this is the kind of thing I would be happy, like I'd also be willing to mess around with putting SP caps on the Master, except the Master has that obnoxious dual BIOS thing, so it's just like, what a waste of time. So yeah, and also the Master doesn't have two PCIe slots, so it's just kind of like, you know, why go through all that effort for a motherboard that is only really good for like CPU and memory overclocking when this is so much more flexible. You can run quad GPU setups on this, which the 5950X is just so good for like quad GPU, well, everything, like old benchmarks with old quad GPU setups with a 5950X. So good. Like the 5950X absolutely destroys Firestrike and Vantage. So, you know, yeah, that's kind of why I'm sort of toying with the ideas of modifying this board to be even better, because I have a lot of GPUs that'll probably end up running in this board. So anyway, that's the V-Core VRM taken care of. SoC VRM uses more of the same 60 amp DRMOS components, so that's, you know, totally overkill there in terms of power delivery. The memory VRM is the classic Gigabyte RT8120 Richtech controller controlling a high side, low side, and another low side MOSFET. These are 4C06Ns? No, 4C10Ns? 4C10. Yeah, it's in my notes. What an idiot. Oh, just look at your notes. Why would you try to remember this? Yeah, 4C10Ns from On Semiconductor. And these aren't great MOSFETs, but the DDR4 doesn't really pull any power, so those are totally acceptable here. The one complaint I have for the memory VR, well, kind of a complaint I have for the memory power delivery is that the BIOS only goes up to 2 volts. But I ended up modifying my board's memory voltage range already so that it would go up to higher memory voltages, and the Ryzen memory controller really doesn't like super high VDIM. Like, it has real training issues. Like, if you go from 2 volts to 2.1 volts on, say, an Intel memory controller, it normally improves your memory overclocking range. On Ryzen, it causes a bunch of training issues. Like settings that would previously be stable now give you an F9, right? So that's kind of the... So, like the 2 volt voltage limit here, like there are other B550 boards that don't have such a voltage limit. Like the Unify X goes up to like 2.3 volts. The only issue is, because of Ryzen's memory controller, when you go up to those extremely high voltages, a lot of the time it doesn't train. So the extra voltage range that I added to the board, not very useful. Which I kind of expected, because I've honestly run into some CPUs even complaining about like voltages higher than 1.95 volts, which is so annoying. Because a lot of B die scales to over 2 volts, and then it's just like you try to run it on Ryzen, and it's like, okay, let's go over 2 volts, and then the memory controller goes, no. Yeah, I added the extra voltage range anyway, because maybe someday we'll have an AGSA that works at high voltages, or I don't know, maybe if I sift through enough BIOS versions, I'll find one that works properly at super high voltages. Or maybe there's some memory chips that don't cause issue. Maybe like E-die would work. E-die's, yeah, I might have to try that with E-die. By which I mean the 4 gigabit Samsung memory chip. Not really useful for any competitive overclocking these days, but it's a memory chip I'm a big fan of because it just doesn't care. It's great. It's a really, really fun memory chip. It's just not very, like, in terms of performance, it just gets, like most memory chips, it just gets completely obliterated by Samsung B-die when it comes to actual benchmark performance, which is kind of, like, DDR4 is kind of sad in that, where, like, DDR3, you have a very large variety of memory chips that are capable of being competitive, and then on DDR4, it's like, is it B-die? Well, if it's not B-die, it's not competitive, so, yeah. But, anyway, yeah, so that's the memory power delivery, which, classic Gigabyte there. Where was I going with that? Right, modification, and then the topology itself is just the standard Gigabyte 6-layer shielded daisy chain. And so if you have this board and you only have 2 memory sticks, they should go over here. And the board even tells you. And yet I've seen way too many people not read that label. Yeah. Anyway, I've had the board all the way up over like 5,000 megabits per second on Samsung B-die, of all things, which is really hard. B-die does not like going to super high frequencies like that. It puts way too much load on the memory controller. Anyway, what else is there? That's kind of it. Right? Like, yeah. Just a very, flexible B550 motherboard. I think that's the best way to describe it. Like, it's not the most powerful VRM to ever be put on an AM4 motherboard, but it's more than powerful enough to power anything you're going to put into the socket. You get a postcode, which is, in my opinion, the most important feature for memory overclocking on Ryzen CPUs ever. There's no safe boot button because safe boot doesn't work on Ryzen, thanks to AMD. Then you've got the PCIe, you actually have 2 X8 PCIe slots, so if you want like more M.2 devices, or if you want capture cards or whatever, you just have more PCIe slots available to mess around with that. I guess the only thing that's not very flexible is the 4 SATA ports. There's really, like, a lot of other motherboards will have 6, maybe even 8 SATA ports, and then you end up in the situation where, like, oh, if you install some extra devices, you start losing SATA ports. I don't think this board does that at all. But at the same time, it also just doesn't have that many SATA ports in the first place. And then the rear I/O just has a ton of options. Not the most USB ports of any motherboard I've seen, but you've got options. You've got DisplayPort input, Thunderbolt, Wi-Fi 6, dual 2.5 gig LAN. Like, yeah, board basically has a little bit of everything, and that makes it one of my favorite AM4 motherboards because just, yeah, it does do a little bit of everything. The one thing I really wish it had was SLI. If it had SLI, then I would be able to ditch the B550 Strix that I bought. Because, yeah. Anyway, that's it for the video. Yeah, the B550 Vision D-P is just a very, very cool B550 board, and yeah. Anyway, that's it. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. And that's it for the video, so thank you for watching, and goodbye.